So these are two limiting reactant example problems that are from the Canvas worksheet that I have put for this chapter. So let's talk about these with regards to the concept of limiting reactant. So let's say I have this balanced chemical equation and I give you amounts of two reactants in moles. Specifically, I have 3 moles of copper 2 oxide and 3 moles of NH3. And I want to know what the limiting reactant is, and I want to know how many grams of nitrogen gas, the product nitrogen gas, are produced. So when asked about limiting reactant, you need to remember that the limiting reactant is the species that produces the smallest amount of product. In this case, it's going to be helpful if we calculate how much nitrogen gas, that product, is produced by both of these. Because, first of all, this problem asks how many grams of nitrogen are produced. But we can also use the information from the calculation to determine which molecule is the limiting reactant. When I do a calculation with copper 2 oxide, I determine how much nitrogen gas it produces. And then once I do a similar calculation with NH3, I compare those two numbers, and whichever reactant gives me the smallest amount of nitrogen gas is going to be my limiting reactant. So let's go ahead and do that. So with limiting reactant problems, we need to do 2 separate calculations. We need to take both reactants and calculate how much product is produced from those reactants. So for the first equation, for the first calculation, we're going to start with 3 moles of copper 2 oxide. We're going to use the coefficients of the balanced chemical equation to relate moles of copper oxide to moles of nitrogen gas. And so from that balanced chemical equation, we can say that for every 3 moles of copper 2 oxide, there is 1 mole of N2. We write that conversion factor so that our mole units cancel. So we're left with moles of N2 in the numerator. We need to get to grams of N2, so we're going to use the molar mass of N2. So the molar mass, or the atomic mass of nitrogen multiplied by 2. We write that so that our mole units cancel, and we're left with grams of nitrogen. So that's the setup that we would do for the first calculation, or for the first reactant, to determine how much nitrogen gas is produced. We would do something similar with the second reactant, with the 3 moles of NH3. Making sure that we use the proper coefficients from the balanced chemical equation. We can go from moles of NH3 to moles of N2 by saying for every 2 moles of NH3, there's 1 mole of N2. And then using the molar mass again of nitrogen, of N2, to go from moles of nitrogen to grams of nitrogen. And again, both of these are written so that my units cancel properly. So when I do these 2 separate calculations for the first one, you should get 28.0 to 3 sig figs grams of nitrogen gas. And for the second, you would get 42.0 grams of nitrogen gas. So these 2 numbers, these 2 product amounts, are the ones that you compare to determine what the limiting reactant is. The limiting reactant always produces the smallest amount of product. So that means that our copper 2 oxide is what's limiting. And the limiting reactant is always what produces the actual amount of product, also called the theoretical yield. So in this case, how many grams of N2 are actually going to be produced? It would be 28 grams. So let's do a second example, very similar. But in this example, I've given you a chemical equation, but hopefully you can see even without the little hint here that it is unbalanced. And in doing these problems, it's very important to have balanced chemical equations. Number and type of atom on the left equal number and type of atom to the right, because those coefficients relate moles of product to moles of reactant. And if those conversion factors are incorrect, then your final answer is going to be incorrect. So you should always make sure you have a balanced chemical equation when doing these problems. And so hopefully you can see that while my silvers, my AGs, are balanced, I have one NO3 chunk here, but on my product side I have two NO3s. That 2 goes to everything that's in the parentheses. So to get two NO3s on my reactant side, I need to add a 2 in front of the AgNO3. That means, though, that I also need to add a 2 in front of the silver chloride, AgCl, to balance out my silvers. And that works out great because I now have 2 silvers as well as 2 chlorines. And hey, I've got 2 chlorines on my reactant side as well. So my chemical equation is balanced. And now we can go on to do the bulk, the meat of this problem, which is to figure out what is the limiting reactant and what mass of AgCl silver chloride forms. And you're going to do this problem in almost the same way as you did the previous one, but you'll notice that the reactant amounts I gave you this time are in grams, not in moles. That's okay. We can get to moles very easily by using the molar mass of that species. So let's start with our silver nitrate. We're going to start with our silver nitrate, amount of silver nitrate, convert it to moles using the proper molar mass for silver nitrate. Then going from moles of silver nitrate to moles of silver chloride by using the coefficients of the balanced chemical equation. For every 2 moles of AgNO3, I have 2 moles of AgCl. And then I use the molar mass of AgCl to go from moles of AgCl to grams of AgCl. Doing that calculation gives me 16.9 grams of silver chloride. So that's how much I would get if AgNO3 was limiting, but we need to see about how much we get with the calcium chloride and then compare my product amounts to determine which reactant is limiting. So we're going to do something very similar with the 10 grams of calcium chloride, converting it to moles of calcium chloride using its molar mass, then going from moles of calcium chloride to moles of AgCl using coefficients of the balanced equation. In this case, also realizing that for every 1 mole of calcium chloride, there are 2 moles of AgCl. And then using the molar mass of AgCl again to go to grams. When you put that string of numbers in your calculator, you should get 25.8 grams. So remembering that the limiting reactant always produces the smallest amount of product. What is the limiting reactant? What reactant is limiting? The limiting reactant is AgNO3. And what mass of AgCl forms? The mass that's formed, the product mass, always comes from the limiting reactant. So in this reaction, 16.9 grams of AgCl would form. So those are 2 examples of limiting reactant problems you'll have in this class. I believe there's one more on the Canvas worksheet that you should try, and I will try to put some more examples as well on Canvas, as well as for the online bonus.